At the end of the chapter, I'll collect it per usual. We're going to start with vocabulary for today for bell work. I told you to just kind of sketch it out, and that's what I'm going to be doing as I go over this, is mainly focusing on pictures. So circumference should be very familiar to you as a vocabulary word. Circumference is the distance around a circle. So just if I was to say it in like a few words, 5 words or less, distance around a circle. So if I was to draw a circle, then circumference would be like the length around it, like perimeter. And the equation that we use for circumference is circumference equals pi times diameter. Then from there, we're going to move down here. Arc length. Arc length is what we're focusing on today. Arc length would be the length of an arc, just like it sounds like. Length of an arc of like a circle. So we have a circle, and let's say they want to know what the length is from P to Q. It would be like a portion of the circle. So let's say that they have like this kind of drawn out. They say that this is maybe 50 degrees and this is 50 degrees. It's not asking for the degree measure. It's not asking for like the like what fraction of the circle that is. They're asking for actually a length. So we're going to be looking at like maybe 5 centimeters or something like that. So arc length would be the length of just this part. Then radian, they took this out of the geometry curriculum. So I don't know why it's still in the textbook, but according to the test specs, radians is not on the test. So we just want to cross that right out. Then sector of a circle is exactly as it sounds. If you have a circle and it's broken into a piece, this would be like a sector, like a piece of the pie. So one of the lessons in this chapter, we're going to find the area of just the sector, which is a piece of the circle. Next, then moving up to the top, center of a regular polygon. Pretty self-explanatory. One thing that you might not notice is regular doesn't mean just like regular. It actually means a lot more than that. Regular means that all sides are equal and all angles are equal. So it's like perfect. So I'm going to try to draw a perfect polygon like this. Not bad for freehanding it. There's our regular polygon. Center would be, the center. And then radius of a regular polygon. So I'm going to draw a polygon, draw her. Same thing. Radius is exactly what it sounds like. The only thing that you might second guess is like, are you drawing it to the corner or are you drawing it to the side? Like, what do they want? They want you to draw it to the corner. So it's the distance from the center to a corner, which because everything's like the same measure in a regular polygon, this length would be the same to every corner. Okay, then central angle of a regular polygon. So again, trying to draw that perfect polygon again. Central angle would be just this angle right here. Draw 2 radiuses to each corner, and this would be your central angle. And then in a perfect polygon, so 360 divided by 5, whatever it is. What's 360 divided by 5? Anybody know off the top of their head? Where'd my calculator go? There it is. 72. So like if this is 72, then all the central angles would be the same measure. And when we go to find area of these polygons, you can actually use the triangles to find the area. So just FYI. Okay. Population density. This is something that's coming up in this chapter as well, something a little bit more real world. Population density is a ratio. People, wait, why can't I spell people? People per, usually square mile, but per any unit that you're looking for. So if you had like a bunch of people, or if you had a bunch of these people over here, and then you were to map out this city into square miles, well then, just get those dots down, Okay, and then you like mapped out the square miles in a city You'd be looking for how many dots were in each square, or average in each square. We're actually going to do a one-day project on population density next week, and we're going to look at the population density of Disney and when the best time to go is based on the population density, which will be kind of fun. Okay, that's about work.